We created this cart for a customer that was simulating human suction, like how hard we suck on a straw, so they could test their product, which is a water bottle. And what we have in the system is, first we have the source of the vacuum. Here we have an ID3 vacuum pump. The ID3 vacuum pump is connected to the back of our Snap vacuum controller. It's going to maintain the pressure at a particular suction. That's then connected to this chamber here, which is basically a ballast chamber, so we can maintain a specific vacuum level despite suction over time, and also acts as a repository for water so we can drain it out. Then we actually flow through a water flow sensor. So this water flow sensor is telling us how much water is actually flowing at any particular time. And as you might gather, the greater the suction, the more the flow. So this is the system that we created, and the nice thing is that it's on a card, it moves, you can shove it in the closet when you're not using it, or you can pull it out when you do want to use it. Let's see how it works. We turn the vacuum pump. We're going to press set point. We have the set point set at 650 torr, so that's not a lot of sucking pressure, or sucking vacuum. So we see that very quickly this tank is regulated to 650 torr, and now we're ready to do our experiment. So what we'll do is we'll take that breath, which for us is we're actually going to turn this valve on, and then we can see that we're flowing about 1.4 liters per minute. Pretty interesting, right? Now, what happens if we actually suck harder? So let's do that. So let's change the vacuum level a little bit lower, say to 600 or 550, let's say. So another 100 torr less. So now the Snap will bring the vacuum level down pretty quickly. Okay. So we'll wait for it to be 550. And now we'll go ahead and see what change that has. Now it's 2.3 or 2.4 liters per minute. So the greater the suction, the more fluid that we would get. And that's the nature of the kind of experimentation this